Hey, how's it going? So we'll be looking at factoring trinomials when a is equal to 1. When I say a is equal to 1, I'm talking about the leading coefficient. The leading coefficient is the coefficient for the term with the largest exponent. The largest exponent in this term, in this polynomial here, is 2. The coefficient for that term is 1. So now when the leading coefficient is 1, now we can follow the structure that we're going to show for the rest of this video. So the leading coefficient is 1, it's the trinomial. And you want to factor, you need to find two factors that multiply and give you 10, which is the constant here, and add and get the middle term, which happens to be 7 here. So if you think of the constant 10, you have 10 and 1, because 10 times 1 is 10, and you have 5 times 2, because 5 times 2 is 10. 5 and 2 also add and get 7, so those would be your two factors, a positive 2 and a positive 5. So you would write that out as x plus 5 and x plus 2. Those are my factors. This is my factored form. This factored form is equivalent to your trinomial initially. If I typed in this equation and I typed in this in Desmos, I would get the exact same graph. Now from here we need to find our x-intercepts, zeros, solutions, and roots. Those are all the same thing. It's just these are four different ways of saying your x-intercepts. Where does your function cross the x-axis? So from here you would take each factor and set it equal to 0. So you would take x plus 5 and put it equal to 0, subtract 5 on both sides, and you'll get x equals negative 5. You would take x plus 2, set it equal to 0, and then you subtract 2 on both sides, and you'll get x equals negative 2. So then those are my two zeros, x-intercepts, solutions, or roots. Now the question might comes up sometimes of, man, what if I'm struggling getting to my factor form? You can always just type it in Desmos and then look at your solutions first. So my solutions are negative 2 and negative 5. My factors are going to be x plus 2, x plus 5. All right. So let's go ahead and look at another example. So I want to find two numbers that multiply and give me negative 20, but add and give me 8. So with 20, we could say negative 20 and 1, 1 and negative 20. Negative 5 and 4, negative 4 and 5. And then we also can say negative 10 and 2, 10 and negative 2. All right. And out of those factors, 10 and negative 2 are the two terms that if I multiply, I get negative 20. But if I add 10 and negative 2, I get a positive 8. So then those are my factors, 10 and negative 2. So we have an x plus 10 and an x minus 2. So when it comes to our solutions, we take each of those factors and set it equal to 0 and solve. X plus 10, and you set it equal to 0. Subtract 10 on both sides, you get x equals negative 10. Take x minus 2, set it equal to 0. You add 2 to both sides, and you get x equals positive 2. So if you look over here at the graph, you can see that it crosses at 2 and negative 10. But because this is Algebra 1, and you're going to have this on your end of course test, the Desmos, you can type it in the Desmos and see where it crosses the x-axis. And then whatever those solutions are, you can just honestly kind of work your way backwards. All right. So if I know my solutions are negative 10 and positive 2, I know my factors are going to be x plus 10, x minus 2. All right. So if I look here, what are two terms to multiply and get negative 18, but add and get negative 3? That would be negative 6 and 3. All right. Because negative 6 times 3 gives me negative 18, and negative 6 plus 3 gives me a negative 3. All right, so then those are my factors, x plus 3 and x minus 6. And then my solutions, I got to take each of those factors and set it equal to 0. So what could when I set x minus 6 equal to 0, I get 6. And then when I take x plus 3 and set it equal to 0, when I solve, I get x equals negative 3. All right, so then those are my two solutions, which you can see here because that's where it crossed the graph. But once again, because you have Desmos in your assessment, you could type this in and then you will see where they cross the x-axis. Those are your solutions, your x-intercepts, your roots, or your zeros. And then you would flip those signs, really, in order to find your factor form. All right? So then if I look here, two numbers that multiply and gives you 4, but add and gives you a negative 5. So then you have 4 and 1, but then you're like, wait, that gives me a positive 5 when I add it. So then negative 4 and negative 1. All right? And then negative 2 and negative 2. But the two factors would be x minus 1, x minus 4. All right? Because negative 4 times negative 1 gives you a positive 4. Negative 4 plus negative 1 gives you a negative 5. From here, take each factor and set it equal to 0 and solve. When you take x minus 1 instead of equal to 0, you get x equals 1. When you take x minus 4 instead of equal to 0, you should get x equals 4. And as you can see in the graph over here, 1 and 4 is where it crosses the x-axis. So then now we have 6 more examples. So if I say what two numbers multiply and give me 12, but add and give me 7, that's going to be 4 and 3. So that means I know that my factors are going to be x plus 4, x plus 3, and my solutions are going to be x equals negative 4 and x equals negative 3. Notice the difference between your factors and your solutions. So if I say, look at the next one, and I say, man, what multiplies and gives me 8, but adds and gives me 9? 8 and 1 multiply and give you 8, and you also add those, you get a positive 9. So 8 and 1. So x plus 8, x plus 1. Then now your solutions are going to be negative 1 and negative 8. That's where it actually crosses the x-axis. Now we want to see what multiplies and gives us 21, but adds and gives us a negative 10. This one gets a little tricky. All right. So we know it's positive here, so we got the two factors have to both be the same sign in order to multiply and get a positive. But then you got to add and get a negative. So that's kind of a hint to say both of these are going to be negative then. So let's look at negative 7 and negative 3. Because I multiply those, I get a positive 21, and add them and get negative 10. So my factors are x minus 7, x minus 3, while my solutions are x equals 7, x equals 3. Notice the difference between your root solutions, x-intercepts, versus your factors. They're different signs. All right? You should be able to take your factors, solve, and then that answer is your solutions. So then if I look here, what multiplies and gives me negative 12, but adds and gives me a positive 4? So I need to multiply and get a negative number. So that means one needs to be positive, one needs to be negative when it comes to your two numbers. And then I need to add and get 4. So that means my largest one needs to be positive, because when I add them, I need to get a positive value. So 12 and 1, that wouldn't work, because then 12 and negative 1 give you 11. Negative 12 and a positive 1 gives you negative 11. If you look at 4 and 3, negative 4 plus 3 gives you negative 1. 4 plus a negative 3 gives you a positive 1. We need 4. So let's keep going. 6 and 2. 6 and negative 2, when you add those together, you get that positive 4. All right, so then those are our 2. 6 and negative 2. So then those are our two factors. And then you set them equal to 0 individually and solve, and then those solutions are going to be your x-intercept solutions, roots, zeros. All right, so now let's look at the next one. Two numbers that multiply and give you 30, but add and give you 13. So then 30, we'll hop right to it, 10 and 3. Because if I take 10 times 3, I get 30. If I add those two, I get 13. So x plus 10, x plus 3 are my factors, while my solutions are x equals negative 10 and x equals negative 3. And then now for our last one. Two numbers that multiply and get negative 30, and add and get a negative 1. If there's no number written in front of this coefficient of x, that's a 1 here. So then you know you need to multiply and get a negative number. So that means both the numbers you're multiplying, one needs to be positive, one needs to be negative. And when you add them together, the largest number should be negative because you need to get a negative 1. And that's another hint is, if you need to get a negative 1, that means the two numbers you're multiplying should be 1 away from each other. So then if I know 6 and 5 give me 30, 6 times negative 5 give me negative 30, but if I add those, I get a positive 1. So I would need a negative 6 and a positive 5. So I'll get x plus 5, x minus 6. And those are my two factors, while my solutions, I got to take each of those factors and set it equal to 0 and solve, and I should get x equals 6 and x equals negative 5. So if I actually graph this, this function is going to cross the x-axis at 6 and negative 5.